I'm going to do a quick review on this UNI-T LCR meter. Do a little comparison with the DE-5000 as well and see how it goes. Stick around. So this meter came to me for free from Banggood, so thank you very much Banggood for sending that to me at no cost. Usual disclaimer. So let's have a look at this thing. Now, I've already had a little bit of a play around with it, I have to be honest, and you can see that the box arrived a bit dented and mangled up, but thankfully this thing arrived fine, and there's a good reason for that. And that's because it comes in this big rugged case, which is quite nice indeed. It feels quite robust. You know, it looks okay. You know, it's quite thick plastic. It can take a bit of a beating, I think. So obviously, it survived the postal system, so it can't be too bad. It can take quite a bit if it can survive being posted. You know, the posties are being careful about things. Yes. Anyway, so let's open the case up. Let's have a look. Show us inside. So you get a manual, operating manual, which appears to be, in this case at least, entirely in Chinese. Now, if you can read Chinese, then you'll be alright. I can't. But it does tell you the specs and things like that, and the ranges and minimum resolution, stuff like that. Now, I did use my phone. I put my Google Translate on the phone and we just went through the manual with that and had a look. And there was nothing particularly exciting about what's in here. It's all pretty straightforward really compared to what you actually get in the user interface. So I do have some questions though about how some of this stuff works, because it doesn't seem to actually be what you might expect. You've got some little warranty card thing here, yeah, and there's a CD, because it does actually have a USB connection. You can plug it into a computer and use it, so it comes with some software on here for that. Now, I don't have a PC, I have a Mac, so I'm not going to be testing that because I don't have anything to test it on. Well, I do, but it means messing around a lot, so I'm not going to actually test the PC software now. If there's enough interest, maybe I'll look into this and actually load the software up onto a PC, but unless there's specific requests for it and more than one, then I won't bother. You know, it's got PC software. It's not something I'd use anyway, so it doesn't matter to me. Now we've got a jumper link here, a shorting link. Now you notice there's no slots on here, and that's because it's got this adapter which you plug into the front, which has got slots on it, so you just plug it in and then you've got your slot, and you can put your shorting link in here for doing calibrations, just like that. Okay, that's how it's designed anyway. So you can also put capacitors straight into these slots, which is quite a common way of doing things. Then we've got obviously the meter itself. It's got a nice soft rubber case here on the outside, bumper case. It's got a tilting barrel, which I haven't actually got out yet. So look, there we go, tilting barrel on the back there. Screwed battery compartment. I should actually look at opening this up too, actually. Shouldn't I do a teardown on it? So look at the battery compartment, I'll show you that. So it's a screw into plastic, so it's not a threaded insert, which is a bit of a disappointment in a way, but yeah, shouldn't have to change it that often. And there's a screw there for getting to the case. And it just takes a 9-volt battery, which is nice and simple. Well, I might do a teardown on this as well as part of the review. We'll see how we go. Survived 2 times so far. So we've got frequency, calibration button, insert and hold button, and sorting as well, and light and setup. Now, function means you can switch between testing modes, power button, USB interface enable, series and parallel, connection, relative measurements, dissipation, quality factor, phase, and it also has ESR as well. The ESR is the symbol which isn't on there, which I thought would be the one which should be there, but it does ESR too, it doesn't show it. And also you've got the 4 terminals along the bottom here, 2 middle ones are guard, and you've got positive and negative terminals there for testing. So it comes with a tweezer cable and a USB cable here for connecting, so it's got a kind of interesting USB connection there. It's not like a standard type. It's a bit like a mini, but it's not. It's a bit weird. You know, in this sense it's a standard USB-A connection for the computer. So I've got some kind of proprietary USB there, which is a bit interesting. And the tweezer cable, they come in these little bungs which you put in there to stop these things collapsing. I always take them out and never seem to put them back in again. That's why they're floating around the case. Now, when I got these, the first bad point, I suppose you could say. I've got these tweezers out of the packet, got them out of the box, unwrapped them because they're all cable tied, you know. Looked at them and thought, that's weird. And I'll explain why. When I went to look at the tip, and you see one's a bit wonky, one of them was actually bent over backwards. It was actually like, I think it might have been this one that's bent over backwards, I can't remember which one it was. One was actually bent, folded over backwards so that things wouldn't actually touch together. It was already damaged out of the box, you know, before I even got the thing. So, and if you look at the tips, you can actually see probably that one is actually slightly thicker than the other, which is a bit weird. You think they'd be the same. And they are very thin and springy. You see how much springiness there is in there. But I think this is the one I bent back to try and get it so it's like right, but it's not actually sitting right. So that's a bit of a failure in the first part. The other thing I've noticed with this is that with these tweezers you can't get very reliable readings. I tried to do a calibration on these. I couldn't actually get it to calibrate on a short. Even though if I touched them gently it wouldn't calibrate, it'd fail. If I touched them medium it would fail. If I squeezed it quite hard it would still fail. I couldn't get a reliable connection on these tweezers. And you'll see this when I do the measurements on the meter here. So I think the failure of this unit is going to be these tweezers, because the quality and the tweezer itself just doesn't appear to be there. The meter seems fine, the tweezer not so much. But thankfully, because it's got these standard jacks, you can actually replace these with something else. You know, such as a crocodile clip lead or something. It won't be as good, but you might be able to even cut this tweezer off, put a decent tweezer on. I don't know, but you shouldn't have to do that. So, I mean, on Unity's part, this is a bit of a fail, because these are not up to standard really to me. These aren't very good. This is what lets it down, I think, is this tweezer, which is a shame, because I think the meter itself isn't too bad. Okay, so let's power this on, see how it goes. Now, I've got some capacitors over here already prepared to test and just demonstrate the values and stuff like that. So I've got this little jumper here which I'll use for the capacitors, so I'll use that for these. But I want to demonstrate these tweezers because this is what I think is going to be the issue with these. So I'll power it up. Now this actually seems function wise to be very similar to my DE-5000 here. Looks like they've tried to copy a lot of the features that this has. It seems to have done that way anyway. So even like the way the calibration is done, the way you control the button to do the calibration, is exactly the same as the way you do calibration DE-5000. So this is the meter I've had for a couple of years now and it works really well. I've been very happy with it. So I thought I'll just try something else. You know, the only thing I've had to do with this DE-5000 is that when you turn it off and turn it back on again, it doesn't remember the previous setting that you use. You know, if you're always using a certain configuration, it doesn't remember that, which is a bit of a shame. Now fortunately, this does the same thing. I was hoping this would be different. I was hoping this could actually remember the previous setting. I haven't found any way of making it save the setting, so it will do the same one each time it powers up. And it always defaults to automatic LCR mode, just same as the DE-5000 does, so there's no difference in that regard. So let's plug these tweezers in. Now you notice it's got, the tweezers have a plus and minus on them, alright? You can see it on camera there maybe. There's a plus just there, minus just there. So you've got polarities on here. These leads don't have polarities. So what's the point of the plus and minus? Doesn't seem to matter. Anyway, you have to wonder. And the same, you know, on here, plus and minus. But which one's which? No idea. You put red to red. Yeah. You have to wonder a little bit about that. When I tried to do calibration on this tweezer, I couldn't actually get reliable measurements. I couldn't get it to pass calibration. It took a lot of effort. Because doing a calibration open was fine, but trying to do a calibration closed, it would fail. Even the slightest little movement of the tweezer and it would fail calibration. So if I look at resistance here, let's try and measure inductance right now. Let's go resistance. I'll see how it goes. I'm just moving it very slightly. You can see the readings just like jumping all over the place, and that's with almost no movement. Depending on how hard I squeeze them as well. 5-6 times. They're still touching together. Right, zoom in a bit more. You see they're still definitely touching. I'll release it slightly. And it actually goes down a little bit. So you squeeze it harder and it goes up, and it's just you cannot rely on a connection from these tweezer tabs. You know, you can see it's open there, that's touching, you get a really good resistance right there. But you squeeze it a little bit more and it changes, and it's just, you can't rely on these tweezers. These tweezers just they're not very good. So I even tried getting on here with my fiberglass brush and just giving it a bit of a slight brushing to try and improve the connection in case there's a bit of tarnishing, and it actually improved it, believe it or not. So what you see now is after I've improved it. Yeah, these tweezers really aren't, to me, acceptable. They just don't do the job very well. Okay, so let's test the component. Right, let's stick it back into capacitance, or auto LCR mode, and let's test the cap. Stick it across here. What do you think of this? 3.3 microfarad, 0.065 dissipation. Okay, and that's that 1 kilohertz test. What is it? It is a 3.3 microfarad, 50 volt. So let's get my trusty DE-5000 in here, and we'll see what this meter thinks of it. Now, they're both just been calibrated before I started doing the video, so they're both as accurate as they're going to be. And we'll see what this one thinks of this. Same capacitor. It also defaults to 1 kilohertz. So basically there should be the same settings. Stick this on here. 3.3, 0.65. So they basically are agreeing. Right, so that's fine. If I change frequencies to say 100 Hertz on both of these, and we'll retest that. So you get 3.566, 0.025 dissipation. Come on. 0.549, 0.025 dissipation. So they're basically agreeing, which is a good thing. What we'll also look at then is we'll look at, you won't let me change because I'm in auto mode. You have to go to manual capacitance. I'm in series still, so what it's got the S for. And then I can do ESR. If it slips on slip, again these, I don't like these tips. ESR 11.9 ohms. Okay, that's at 100 Hertz, and we'll do the same on this one. Again, you have to work it the same way. You have to go into capacitance. Now I've got to go series capacitance, and I will do ESR over here. Test it with this one. 11.3, 11.4. So they basically agree, which is a good thing. Means this is going to be as accurate as this, it would seem, at least on a small value. Let's try a different value. This is a 33 microfarad. We'll leave it at 100 Hertz. So it's 33.5, 2.5 ohms. Do the same on this one. See, this keeps on happening with this tweezer. It just slips off all the time. .5, 2.3 ohms. That looks okay. Next one. 213 microfarad, 0.2 ohms. .10 microfarad, 0.2 ohms. So it's starting to see a slight difference there. So you go 2.94 millifarad, 0 ohms measurement. That's a 3300 microfarad. What does this one think of it? Every time. Oh, come on. Right. Got to hold the thing, haven't I? So you've got 3 millifarad there, 0 ohms as well. So, slight difference. And the last one here is 10,000 microfarad, 25 volt. So 9.28, 0 ohms. Check out the DE-5000. 9.29, 0 ohms. Again, very accurate. Right, so these are agreeing to the most part, at least. So let's change frequencies again. Let's go back up to 1 kHz. And we'll test this medium sized one again. This should give us slightly more resolution. That one there is an overload on that value. I'll go to the next one down there. We'll try it on the other one as well. So it's a 297.18 ohms. .06.09 ohms, 0.08 ohms. So there's a bit of a discrepancy between these two at that frequency. So is it frequency related? Possibly. I could actually measure that. We'll try this other medium sized one, which wouldn't, the DE-5000 couldn't read. See if this can read it. No, I can't read it. It's over range at that 1 kHz, which you expect. I mean, these bigger caps are usually 100 Hz rated anyway, so 1 kHz usually for smaller caps anyway. So that's not unsurprising. So okay, well that's that. That's the capacitance. Obviously, we've got the inductance and the resistance ranges as well to check out. Now, to be honest, although it's an LCR meter, I don't tend to use it for resistance or inductance. Although I've used it for inductance, but I don't tend to use it for that. I'm mainly checking capacitors because that's what I'm always testing, is capacitors. I'll go and grab some inductors and come back. Okay, so I've got these sets of inductance. I'll grab just a couple of inductors. So we'll try it on the UNI-T first. It's not ideal with these tweezers in this way, but I could actually do the slot testing, but it's calibrated for the tweezers right now, so let's just try and get it to grab hold of that without me touching the connections at the same time. One on capacitance. Oh, it's supposed to be capacitance, supposed to be inductance. $440. I think it's 470 inductance. 445. And Q of 0.47, 0.48. Let's see what this one thinks of it. $450, a Q of 0.51. So they're very close. This is parallel inductance. So we'll try this other one, which is, I think it's 1 ohm. Let's call it a resistor. It's not a resistor, it's an inductor. There you go, 1 microhenry is what the value is. It's 0.7 showing up. Let's check this one. But 1 microhenry. So this one's actually looking slightly better in this low inductance range. And it has an auto ranging as well. Whereas this one actually got it wrong in auto range. It thought it was a resistance. But you notice if you look through these ranges here, you've got LCR auto, right? So they're both auto there. Both inductance, both capacitance, both resistance, both DC resistance. So you can see that this UNI-T does appear to basically be their version of this. You know, everything is laid out the same way. You've got APO, auto power off, although there doesn't appear to be any settings to turn it on and off on either unit. This I know will stay on if it has a DC power supply plugged into it, or won't turn off. Maybe this will be the same. Actually, I can try plugging the USB cable into my DC power supply over here and see if that does anything. We could try that, couldn't we? Okay, so the jack is here, USB port. I've got power plugged in already. That goes that way up. Okay, there we go. Now auto power off has disappeared. So this again works exactly the same way as this, where if it's got external power supply applied, it doesn't automatically power off, it will stay turned on. So that's a nice feature. I wish you could actually turn it off manually in the settings as well. I wish you could do that, but it seems you can't. This one here takes a 9-volt power supply, center positive, and that's how you do that one. But it's got quite a small jack on there. It's not a 2.1mm. I'm not quite sure what size it is. I've never used it, but I just know that's one of the features it has. For comparison sake, obviously, this is the one we're concentrating on. Okay, so that does that. Unplug that again. Auto power off comes back on again. When it comes to these buttons on the front, there's a few weird things I've discovered. You got salting. That works in certain ranges, it doesn't work in other ranges. It depends, right? So you've got a sorting feature, you can set this up, tolerances and that sort of stuff. This is really the setup for the ranges of what you're allowed to have. Now I haven't actually tried playing around this yet. I've got no idea how you're going to set this. Maybe just give it a feed in a value saying this is the maximum, this is the minimum, and that's what we'll allow. I really don't know. Oh yeah, there we go. So you can change it like this. So this is the only time I actually had these buttons here working, is in the sorting feature. Alright. Let's get back out of there. And I haven't really played with that yet, so I did try doing sorting before. Hit double beep means no, so if you're in auto range you can't do sorting. I think I did have it in, so inductance won't let you do it, capacitance won't let you do it, resistance won't let you do it, DC resistance won't let you do it. So I'm trying to find out where it is I can actually do a sorting function. It's a feature somehow. I mean, you saw me get in there just now, but now it won't let me get back in there. Don't know. Yeah. Lack of instructions is a real problem with this. Obviously this has got sorting as well. Again, it's a feature I've never used. It may be something you need to use yourself, but it's not something I use. And you notice it does 2 beeps and 2 beeps. Again, copy of this one. Yeah. Anyway, so let's look at this other thing we've got here. So we have this plug-in module, which kind of aligns. It doesn't seem like it's quite aligned. I'm not quite sure whether it's, I think it's these plastic shrouds. There might be a little bit of distortion on one of them or something. I mean, it just doesn't seem to want to drop straight on. It feels like it's slightly distorted. Not much, just a little bit, to be a bit, like, see, annoying. There, it doesn't want to go on. There we go, now it's going in. It's just a minor. Yeah, no, it's plugged in. It's a nice solid connection once it's in. And obviously there's a shorting bar. So if you chuck a shorting bar in, which wobbles a lot, probably doesn't matter, you're getting 0.19 ohms. So even with a short on the output, well, on the sense input, you're getting 0.19 ohms. Well, shouldn't that be 0 ohms? Let's do a calibration, shall we, and see what we get. So calibrate. Open, yep. Cal. This takes 30 seconds as an open, and you have to do 30 seconds again as a short. Now I did the same thing with the tweezers, and open was obviously fine, but when I tried to do a short, I had a real pain getting this to work. It took about 3 or 4 goes to get this to actually not fail, because of that resistance changing very slightly as you move around just a fraction. It's just no good. These tweezers are no good, as I've said. So that's the open passed as you expect. Just do a short, plug that in. Now it does 30 seconds testing the short. I don't know if there's any other kind of calibrations you can do on this to get that zeroing correct. I mean, you've got a relative measurement here, you can always do relative from that position, but you would think that with a terminal directly in here, with a direct short across it, you should be able to get 0 ohms when it's done a calibration to it. So we'll see what we get. I mean, that was calibrated on the tweezers, as wonderful as they are, and we'll see what this comes up as. So pass, that's right. Cal, and it thinks it's an inductor. Not an inductor. Let's go to resistance, see what we get. Zero ohms on C resistance, and DC resistance 0.02 ohms. So okay, that's definitely better. That's what you expect to get, is a 0 ohm reading when you've got a jumper across there. So let's turn this off, power it up again, see what we get when we do a from fresh short. There we go, 0 ohms. So that's better, that's much better. So with it like that, compared to DER meter again, we've got the slots. Right, so but now we've both got testing slots. So now you can get a component, instead of using a tweezer or a clip or whatever, you can shove the component straight in and measure it directly. Right, which is the preferred method if you've got a component with leads on. Right, so this is a 330 UF capacitor. We're getting 310 microfarad, which is fine at 1 kilohertz. Now can we do this? No, we can't. Exactly the same as DER, designed the same way. You have to first change two capacitance, so we're getting 3.85 dissipation, quality of 2.59, ESR 0.19. Change meters, shove it in this one, let it auto range, 303 microfarad, so it's slightly lower, 0.303 dissipation. Again, we've got to change to capacitance range, and then we'll go to dissipation, quality factor 3.15, which is slightly different again, and ESR 0.17. So readings are very similar between the two. There are some slight differences, but I don't really think those differences matter that much. Maybe it does, but I don't think it does. Okay. Yeah, I mean they're close, aren't they? They're close. This has changed actually. It's now saying 0.19 ohms. So let's change frequencies. Let's go to 100 hertz on both meters. Make sure they're both the same. And we'll look at those same readings again. So let's go series capacitance. Let's change ranges. Of course, it has. Right. So 319 microfarad, 0.2 ohms in that reading with dissipation. We've got phase there of 86 degrees. Dissipation 0.058. Show it in this one. 0.2 ohms, 316 microfarad. 86 degrees phase. 0.045 dissipation. Again, they're very similar to each other, but slightly different. So, yeah. Mine just hasn't been recalibrated the short across here, so I don't think I've got a shorting bar to go across here actually. I've always just used these things. Always use tweezers or clips. That's what I always have connected to it. Okay, let's look at some resistors. So I've got a 1 ohm resistor here, or thereabouts. It's going to be something like that. Let's chuck it in this one first. I've done a recalibration on this, so I used that little wire link to calibrate on these slots. So this is a direct comparison like it should be. So we're getting 1.01 ohms, or 1.013 I should say, at 1 kilohertz. Now this isn't DC resistance, this is AC resistance. And this is giving 1.02 ohms at 1 kilohertz. So if I change the frequency again, I don't get any more resolution out of it, I don't think I can. So 100 kilohertz, we'll do 100 kilohertz on this one as well. See if there's any difference. So 1.025, 1.045. So this one did shift up a little bit with frequency. So let's change to be DC resistance. 1.03, 1.04. Do the same on this one. .03. So 1.02. So don't forget we're measuring 1 ohm. That's a pretty small value. But then these are designed to be able to measure that low. So that's what they're for. Seems okay. So it's working on spec. Now what we can look at next is actually plugging in some leads onto these, some little clip leads, and see how those work. Now another little fail I just found, design wise on this thing, it's only minor, is that you've got plus and minus on opposite sides of the meter. Now quite commonly you'll find plus and minus next to each other. In most pieces of testament they're 90mm apart. The reason for that is that you can plug in a dual banana lead and just go straight in with one connection, bang, into those two. But because these are spread across the meter, you can't do that. So if I wanted to use a precision lead, that doesn't work. So if I get the negative here and plug it to the guard, no reading, right? Because that's what the guard's for. It's not actually part of the circuitry, it's just the shielding. So really they should have been side by side and had the guard over here. This is a bit of a fail on their part, because now I can't use a dual banana lead to plug in to get a precision reading. Okay, because I've got some Pomona leads, which are these, which would improve it for this, right? Because they're dual banana plug, and they've got a guard lead as well, right? So you get really good precision measurements with these because they're designed for that. But because of that, I can't actually plug this in because I won't actually be able to measure it. The only way I could do that is to plug it in like that and then use this one here as the negative, which kind of defeats the purpose of having the guard on the outside. Anyway, so little fail. But you can still plug leads in, which is a good thing. So you can see I've got my Heathkit Deco resistance box set up here. So I'm just going to just chuck some random numbers in and we'll see what we get. Now you can see lead resistance is about 0.12 ohms. Alright, so I could null that out. Maybe. Just give me a... No. Is that going to work? No. It gives you a percentage reading here. It doesn't actually tell you. It doesn't actually null it out. I've never tried it on here. I should try it on here too. Anyway, so let's go. There's some random values. Let's do 5 ohms. 5.3. That's in line with what it should be. Okay, let's do 50 ohms. Yep. 500 ohms. I'm going for middle of the range because it's quite tolerant that way, I suppose. 500 ohms, there we go. Let's do 5k. Yep, can read 5k. I'm not sure what its top spec was. Anyway, this is 50k. Yeah, it can do 50k, although it's a bit slow, isn't it? And then 500k. Alright, so it's going to do mega ohm range, that's okay. So I'm going to turn this relative back off again, maybe that's what's slowing it down. So if I change ranges now, go back from 0 to 500 again, we'll do the same thing. That's still pretty slow. Compare that to a multimeter, that's pretty slow, right? Yeah. Okay, let's do RP instead, then we'll see if we get there. So 100 kilohertz, and we're getting this inductance effect from the cables, and also there's probably wire arm resistors in there too, which are going to be affected. So let's go change frequency back down to 100 hertz. And there we go, we're getting a more sensible reading there. But it is inductive, must be wire round resistors involved in this. It could well be, I don't know, it could be carbon, I don't know what's in it. Let's go down to 50k, yeah. 5k, that's faster, using that range rather than the DC resistance. 500 ohms, yep. 50 ohms, yep. And 5 ohms, yep. So it's definitely faster in that particular range there. Let's swap over to the other meter, as for comparison's sake. 0.18, so similar readings there, slightly higher on this one, the resistance. Okay, so 5 ohms. Again, it's a bit slow, same as this, in that DCR range. So 50 ohms, yep. 500 ohms, yep. 5k. Pretty slow there, isn't it? 50k. Yep. And 500k. Yep. So don't forget, this box isn't a precision reference. Right, it's just a substitution box. So these aren't going to be reading exactly right. You know, I don't expect this to read exactly 500 in either one of them, you know, because this probably isn't exactly 500, for example. All right, and that's also gone to a mega ohm range, same as this one did. Okay, so let's change this to RP, like I did on this one, and again we're getting the same kind of inductive range on there. So let's go back to 100 Hertz, 501 or 500 or so. Okay, that's right. Let's back down to 50. Yep. And again, this is working faster too. So they're basically working exactly the same way. It's 5K. Let's do 500 ohms. Yep. 50 ohms. Yep. And 5 ohms. Yep, 5.22, and 0 is 0.21. So, yep. So they're working identically. Both units are basically equivalent. I think the deciding factor between these is probably going to be cost, because I think this is cheaper. I'm not sure actually. I should look at these. I think there's a newer version of this meter now. Actually, I think it's a slightly different version that's available now. I don't think you can get the 5000 anymore, but there's an equivalent version which is like an upgraded one. I think this is cheaper than this, so that's probably the main factor there. But what this gets is you get two accessories. You get the tweezed lead, which plugs in, you know, with this. And there's also a clip lead, which I think I made. It did come with some other clips, I think, but I actually made one with little crocodile clips on it. So it's like a 4-wire measurement effectively. And yeah, so this works as you'd expect. As I said, I'm not going to try the USB function out. I'm not going to do that. That isn't something I was planning on looking at, unless I have to, right? Because it's a bit of an effort for me to actually go in and do that. If you specifically need it or want it, then I can certainly go and have a look and consider doing it, but it's not something I was planning on doing. I suppose we should try pulling it apart now. Since we've played around with it and look at the outside and see how it functions, let's see if we can get the thing open. Let's get the battery out first. I don't like about battery clips, these 9-volt ones, as they tend to rip the tabs off. I think I've damaged my fingernail. I'm trying to get it off. Come on. There we go. Right. Get the screw here out. Another self-tapping plastic screw. This one here as well. So I think this is just TPE over-moulded. It's interesting, it's got this little blue piece here, like it's like an aluminium pad or something, and it's got this plastic over it. It's like it's supposed to have something there. It's a bit interesting. Is it magnetic? Can't tell, is it? No, I don't know what the story is with that. So, does it open up? Yes, it does. Here we go. It's got a little hook clips up the top, and that's what's up there. So let's fold it over this way. Try and rip the things out. Okay, there's USB port. It's got hot glue on the terminals, on the wires, so they don't break off too easy. Bit of strain relief. That's a nice little touch. And what can we see here? So we've got a display driver. Is it Sirius? Is it? I can't read this upside down. As Dave will say, the electron's going to fall out. Here's a crystal over here. I can't read what this is either. Is it 3.999 megahertz? Is it? Little buzzer which you could hear. There's obviously some SPI ROM or something in there. EEPROM memory of some kind. So obviously the main thing we will look at is the input side. So let's have a look. So what do we have here? We've got a, I don't know what that is. TS3A5017. No idea. There's another one of those there. Here's a, not quite sure what that one is. That device just there. Can you see that? So as close as I can get. There you go. You can read the numbers yourself. Is that an 841GA, is it? Just here? Might be. So there's TS3As. I guess I'm getting the right numbers off them. Some other chip here. 1833. Really? 1833? I'd expect that kind of number in a HP piece of gear, you know, HP numbers. Anyway, so it's probably just a coincidence. ETH 51920A. So it looks like. So we've got some little tantalum caps around the place. I think the tantalums. A bunch of those. Probably a voltage regulator over here. Maybe another one there. Could be references. Entirely possible. There's a few unpopulated parts. This always gets me curious. There's a little trimmer just here, marked VR, helpfully. And there's a P1, which I'm guessing is a programming header, which feeds up here to that device. It's probably some kind of microcontroller. And this is probably some kind of DAC. Don't recognise that logo either. I don't know what that is. So you can see the terminals here. The guards are going to the main PCB shield, and we have comment. Comments instead of common. Interesting. So the 0 volt one is coming to here, which has then got this split traces go to this side and that side. It's also got this like guard terminal right in the middle of it as well. It's interesting. And then you've got the positive side is also split off to a little resistor there and comes up to another one. So it's got two dual paths. So it must be doing some kind of differential 4-wire measurement from this point then. So it must be 4-wire from there. So yeah, it's looking like it's got basically 4-wire running from these terminals. So that's nice, I suppose. Capacitor there. There's nothing really protection wise I'm seeing here. It's not like a multimeter shove of, you know, hundreds of volts shoved into it anyway. It's not like it's that kind of situation. So I'll be surprised if that's necessary anyway. Probably not. It's got a big smoothing cap of some kind here as well. Keeps the noise down, I'm guessing. That's across that line there. That small resistor there. So maybe that's some kind of reference. Clean, making sure it's smooth. Trying to see what these other devices are. See it on there? 35A, is it? What's this one here? Trying to get the light on it right, it's always a challenge, isn't it? Indian focus is the next challenge. Can't quite make that one out. And there's a crystal there, 24 MHz crystal. So there's not actually a lot to see, is there? You know, again, comment instead of common, although they're not the same common, so you're not quite sure where you caught the same thing. Soldering, yeah, well, there's solder on that one, but it's not. I wouldn't say it's well soldered. It's a little bit showing up in here. This one's okay. That one's okay. This one's okay. I'm going to try and get onto this device here. See what that is. Let's try getting closer, shall we? Physically closer. Alright, that's physically as close as I can get. There we go, 7150. Whatever that is. SCJ, I'm guessing that's a number. There's a nice close view, isn't it, actually? It's pretty good. It's working quite well. 1AM, wherever they are. Those transistors. A35 HB up here for Q1. A couple of diode markings, but they're zeros. Not as zeros, which is curious. Looks like they got, yeah, look, 3 series diodes, but looks like they undecided only did 1 in the end. Or they went from Schottky to silicon or something. Hope that's a nice close view for you, so you can actually see quite well. It's not bad, is it? And you go, Vision 00, 1.6 millimeters. Okay, 2016. This is designed. There's our chip there. There we go, the componentry up here. I'll get the numbers of that chip. There we go. DM24002A. And this is ground USB and TXD. So it's one-way communication, and there's the back of the USB board. Just there. Obviously upside down, but you know, so what? Now I get a close up of that actual connector. There it is there. So it's a bit of a strange design. It's not one I'm used to seeing. I don't recognise it. So let's put this thing back together. I think we're done inside. Nothing else to see here. Let's just make sure those aren't going to get pinched. I think they might actually. Make sure it's not getting pinched inside there. That cable. Stick it to one side. Pull the battery one out a bit further. Yep, I think we're good there. No, it's getting pinched again. Okay. Okay. Simple enough. So it's actually, it's right. Yeah. It looks like it's well designed. They thought about 4-wire connections on the side of the board there. You know, having 4-wire internally is alright. I mean, 4-wire externally would have been better. They put some. When they've got 4 jacks, they should have made them all 4-wire connections. You know, I think that would have been more useful having 4-wire on the outside of the unit. But oh well, that's the way it is. I suppose you could maybe modify it and make it 4-wire. Remove the guard terminal. I don't know if it's really necessary though, is it? Maybe. Shove this back together and then we're done. Okay. Time, as AVU would say. Anyway, although he does that when he's unpacking stuff, not necessarily putting it back together. I'd be found that interesting. If you want other comparisons, maybe I'll do some more follow-up videos if there's anything specific you need to know, or ask questions down below in the comments, or give your opinions in the comments, that sort of thing, because I do want to hear what you want to know about these things. If you have questions, I might be able to answer them. I don't know. Maybe I can, maybe I can't. Find out and give me your opinions. You know, if you've got more experience about LCR meters than I have, and a bit more knowledge about LCR meters than I do, please chime in down below in the comments and contribute to educate everybody else that's watching as well, because I certainly don't know everything. I don't pretend to know everything. I'm just a guy which tinkers with stuff. So thanks for watching. Don't forget to subscribe if you're not already subscribed. Click the bell icon, otherwise you won't get notifications about new videos and you won't get notified about them, and so you'll miss out on seeing them. So for your own benefit, and make sure you don't miss out on anything I may publish in the future, make sure you click on that bell icon. Give us a thumbs up if you like the video, and share it if you think people might be interested in seeing this particular meter. And thank you very much to Banggood for providing this to me for free. And it's just a pity about these. This is what lets it down. Tweezers. But that's something you could fix if you really need to. If you really wanted to, you get some better tweezers and swap them out. It's not a big deal really, but you shouldn't have to. It's a bit disappointing. The tweezers what lets it down. Anyway, thanks for watching. Catch you later. And I'll see you next time. And it beeps just like the DER does too. Funny that.